Hello gentlemen, welcome to section 24.4 on organic functional groups. Now, a functional group is a group of atoms that determines how an organic molecule is going to react in a chemical reaction. Now, we're going to go through today different types of functional groups, and here we'll go through our different types of organic molecules or categories and what their functional groups look like in those types of matter. We'll go through the prefixes and suffixes that accompany our different functional groups. I'll give an example of a molecule that has that functional group in it, and then we will name that example. In our names, we'll have present the prefix and suffix of that functional group, and we'll also have the supporting carbon backbone information that we've learned in previous classes. Now, our first functional group is one that we've heard of before, the alkene functional group. Now, an alkene is represented by a carbon-carbon double bond here. The suffix is an E-N-E ending. An example of that would be carbon double bond to carbon, which is single bonded to hydrogens on either side, making it just a unsaturated hydrocarbon, excuse me. And an example of that would be ethene. We have the E and E ending there representing our functional group. Our next one is an alkyne. For an alkyne, we have a carbon-carbon triple bond. And our suffix here is a Y-N-E ending. An example of this would be two carbons triple bonded together, and to satisfy their octet, you have two hydrogens there, and we have ethyne with a Y-N-E ending. Now, a new one for the class, but something that you're probably very familiar with, is an alcohol. Now, alcohol has a functional group as such. It's a carbon, single bonded to an oxygen, which is attached to a hydrogen. This is your alcohol functional group. The suffix for an alcohol is OL. The functional group is here. An example of that would be methanol, CH3OH, with this being the major functional group there. And if you notice, we have an OL ending because it is an alcohol, and it's methanol because we have a one carbon backbone there. Our next functional group is an ether. An ether has a carbon single bonded to an oxygen, which is single bonded to another carbon. So it's oxygen sandwiched in between two carbons. The prefix or suffix really doesn't exist. It's just kind of a separate word on its own, and we'll see in our naming in a moment. Ether. An example of that would be, if I have a methyl group here on either side of my oxygen, with the oxygen in the middle here, we call it dimethyl ether. And here we just put ether separately from the first name here. Our next type of functional group is a haloalkane. In a haloalkane, we have a carbon single bonded to X. X represents any halogen. So any of our group 7A materials or elements, we would insert here. Our prefix that we'll use is halo. An example of that would be if we have a methyl group attached to a chlorine. And here we have chloromethane. So here would be our prefix. We don't put halo here. This should be, we don't put halo, but we actually put the halogen that we're using, the root of that word. So for chlorine, it would be chloro. If it was bromine, bromo, fluorine, fluoro, etc. Our next functional group is an amine. For the amine functional group, we have carbon single bonded to a nitrogen. And the nitrogen is going to branch out twice. Nitrogen is going to make 3 bonds in this case. And our suffix is amine. Pretty simple suffix to remember. An example of this would be if I had this substance here. My functional group portion, would be that portion here. This would be called ethyl amine, because I have an ethyl group here, 2 carbon backbone, and then the amine group attached to it. We remember this from our acids and bases chapter. Most of our amines were considered to be weak bases. That's a connection that we can make to this functional group of amines. Our next functional group, aldehydes. We have a single carbon double bonded to an oxygen, which is single bonded. So the carbon is also single bonded to a hydrogen here. This is an aldehyde functional group. The suffix we would use is al. An example would be if we have a methyl group attached to a carbon double bonded to an oxygen here. So this would be your functional group. We would call this ethanol. It's ethanol because we have a 2-carbon backbone. This carbon becomes part of the backbone here. 1, 2. So it's ethyl. And this Al lets everyone know that it is an aldehyde. You might have heard of formaldehyde before, that substance. That substance is an aldehyde. That's not the systematic name, but that's a connection you can make. Next, we have a ketone. Now, a ketone has a functional group that has a carbon chain, but in the middle carbon, we have a double bonded oxygen. So it's carbon attached to another carbon, which is double bonded to an oxygen, and then that carbon is attached to another carbon. The suffix for this is ONE, own. An example would be if I have a methyl group, and my functional group here in the middle. This is called propanone. So the functional group would be this section here. A very popular ketone that you might be aware of or have heard of before is like testosterone. That ending tells us that it is a ketone. Our next functional group is carboxylic acid. In carboxylic acid, we have a carbon double bonded to an oxygen. That carbon is also bonded to an oxygen, single bonded to an oxygen, and a hydrogen. Our suffix here is oic acid. An example of that would be ethanoic acid. So we have our functional group here. If you remember back to our acids and bases chapter, we oftentimes saw this COOH as being a part of a certain chemical formula. This represents a carboxylic acid functional group. And we said, carboxylic acids were oftentimes considered, or most of the time, weak acids. That's another connection that we can make from previous chapters. Next we have esters. An ester has a functional group that has a carbon double bonded to an oxygen. That carbon is also bonded to an oxygen, and that oxygen is bonded to another carbon. So this is kind of a combination of a carboxylic acid and an ether from before. Carbon, oxygen, carbon, and that carbon is double bonded to an oxygen there. Our suffix for esters is OAte. OAte. An example of that would be if I have a methyl group on this side of my central carbon, that central carbon is double bonded to an oxygen, and another methyl group on this side. Actually, that is not right. Change that. Oxygen here, and then we have that there. And this would be methyl ethanoate. And your functional group would be that portion there. Now, your last one is an amide. An amide has a functional group where your carbon is double bonded to an oxygen, that carbon is also bonded to a nitrogen, and that nitrogen branches out twice. Our suffix is amide. Pretty simple to remember. Just like amine was amine, amide is amide suffix. And our example here, we have a carbon attached to a carbon, attached to a nitrogen. Your functional group is, well, we'll say it's here. This is called ethanamide. And it's right there, and the last one was up there. Gentlemen, please take notes on these functional groups. You're not responsible for knowing every single example or every single name of these functional groups. Just being able to recognize what type of functional group can go with what it, its name or what it looks like. Just recognizing the functional group. So if I said, what is characteristic about an amide, you can say, oh, an amide has this attached to this, etc. It looks like so. You don't have to memorize every single thing about these functional groups. Gentlemen, please take notes. Adios.